Hello, this is mathjazz from Almost Cool. This is the second video in our series of videos of common optimization problems. Today, we're going to optimize a rectangular field that is against a cliff wall. The statement of the problem is, suppose that you want to make the largest rectangular fence field possible at the base of a cliff, and that you have material to make 1,000 feet of fence, and that you can use the cliff wall as one side of the enclosure. What is the area and what are the dimensions of the largest possible such structure? Here's a diagram. You can pause the video now to work out your solution. Here's the solution. Well, first we're going to have to write out equations for the area of the field and the length of the fence that is bounding the field. So the area is x times y, because that's the area of a rectangle. And the perimeter will be 2x plus y, not 2x plus 2y, because the cliff wall does not count towards the amount of fence we're using. So we have x fence on each side and y fence on the side opposite the cliff. So we know that the perimeter is going to be 1,000, so 2x plus y equals 1,000. The next step is we're going to solve for y, and then plug what we get for y into the area equation. We're going to solve the perimeter equation for y. So when we do that, we'll reduce the number of variables and get a single variable calculus problem, and that'll allow us to find an answer. So the area equals x times y, but y is equal to 1,000 minus 2x. So multiplying that out, we get the area is equal to 1,000x minus 2x squared. Next, we need to take the derivative. So the derivative of a is a prime equals 1,000 minus 4x. We set the derivative to 0 to find the critical numbers, and we get 0 equals 1,000 minus 4x. Well, we add 4x to both sides, we divide by 4, and we end up with x equals 250. Next, we're going to plug x equals 250 into the formula we have for the area and the formula we have for y. That'll give us the area, and then 250 and whatever we get for y will be the dimensions of the field. So a of 250 equals 1,000 times 250 minus 2 times 250 squared, which is 250,000 minus 125,000, which is 125,000. That is the area of the largest field. We do the same for y. Y equals 1,000 minus 2 times 250, which is 1,000 minus 1 minus 500, which is 500. This means that the dimensions of this field are 250 by 500, and the area is, again, 125,000. Thank you for watching this video. Contact information is on the screen and in the description of the video down below. I hope that you're enjoying learning calculus, and I hope you have a great day. Goodbye.